All right, good morning, everyone. Today we are going to talk about asphalt. Okay, we have last two lectures remaining, which we'll finish by this week. So asphalt introduction and also asphalt concrete this coming Wednesday. Okay, and then we're gonna finish all our lectures. And from next week, we have our research paper presentation. Okay, for the next three lectures. Okay, so please get prepared. Okay, so before I start, there's another thing I want to talk about again, which is team working. Okay, so every week I will get email from some of you seeing things like some of the team members do not want to involve with the work, okay, uh, or we get email from some of you seeing, several team members will form a small circle together. They finish everything, and I cannot get involved with, and asking how they can deal with that. Okay, so what I say is, as a future civil engineer, teamwork and networking is very important because no civil engineering project is a small project and can be finished by one or two people or even three or four people. Okay, so all phases of a civil engineering project from bid proposal, okay, which is you submit a proposal to bid that project, okay, or all the designing phases. For civil engineering project, we have 10% design, 30% design, 65% design, 100% design. Okay, so all the designing phases, and then we submit the design drawing to the construction company. So construction, we have construction phase. Okay, so you need to deal with the civil engineers from your own firm, from owners firm, and also I don't know, from all construction firms. Okay, so you have to work with other civil engineers. Okay, time in your future career. Okay, that's why teamworking and networking is very important. Okay, so I do not assign different roles in our group. But you need to communicate with each other, like using emails, video conference, for all assignment which will involve teamworking. Okay, so we have lab number 4 and 5. This is group effort. We have research paper. We just submit the abstract. We have high strength concrete design. We have research paper presentation, which will be next week. Okay, so all these group effort will be done by every member together. Okay, so keep that in mind. All right, so today we're gonna talk about asphalt. Okay. All right. So I'm not asphalt expert. Okay, so by no means I'm an asphalt expert. This next two lectures is just an introduction of asphalt materials. Okay. If you are interested in asphalt materials, I think Professor Ricardo Achila, he offers classes, I think 361 or 461, which give you much more details explanation on how to design asphalt pavement. Okay. Today and this coming Wednesday, we just give you an introduction of asphalt as materials, as a construction materials, because this class is introduction of construction materials, including cement, concrete, wood, and asphalt. Okay. Right. So asphalt has been used by human beings for almost 5,000 years. Okay. Today we use asphalt mostly for pavement. As you can see, probably almost more than 90% of the highways, parking lots, are made by asphalt materials. Okay. Around 10% of the pavement is made by Portland cement concrete, but most of the pavement are made by asphalt. Okay, for some good reasons. Beside highways, we also use asphalt as waterproofing materials because asphalt is a semi-solid. It is good sealing materials, so we can use that to seal roofs, leakage on decks, underground foundations, and things like that. And also, of course, patching materials to repair pavement, such as potholes. Okay. The cost of asphalt materials is closely correlated to crude oil because asphalt is a byproduct of crude oil. Okay. All right. So crude oil, everybody knows that is a form of fossil fuel. The other type of fossil fuel is coal and the natural gas. Okay. And in the crude oil is a mixture of many different types of fossil fuel, including gasoline, which we put that in the car, diesel oil, okay, fuel oils, kerosene, jet fuels, and also asphalt. Okay. So crude oil, depending on the source and location, okay, they may change from colors and thickness and the percentage of the different type of oil inside that crude oil. And here shows refining process. So what do we do for crude oil? Okay. So before we do any distillation, we put the crude oil into a settling tank. Okay, because inside oil we have sand and water. So we want the sand and water to separate from the crude oil first before going to the refining process. And then we increase the temperature of the crude oil because we have different type of materials in the crude oil and they have different distilling temperature. Okay, so based on different temperature, we can separate different type of materials such as light distillant, including gasoline, or we have medium distillant, including kerosene. Heavy distillant, we have diesel oil, and the bottom one is called residue. Okay, residue has the highest temperature to separate from other materials. Okay, so inside residue we have asphalt cement, or we have emulsifying agent, and also distillant, which we also use in some type of asphalt cement. We're gonna discuss in a moment. Okay, so the refining process, including separate different type of materials based on different temperatures. Again, the first step is we remove the sand and water from the crude oil, put in the settling tank. Okay. And most crude oil is somewhat acid, so the pH level is less than 7. Okay. Then let's look at asphalt product. Okay. Asphalt used in pavement has basically 3 different type of form, depending on how we liquefy them. Okay. So they are asphalt cement, We also call that asphalt binder. We have asphalt cutback, and we have asphalt immersion. Okay, again, we have these three types of asphalt because the ways we liquefy them are different. But first of all, why we need to liquefy asphalt? At room temperature, the asphalt is semi-solid. But for asphalt concrete, we need to mix the asphalt with sand and coarse aggregate. This is the same as Portland cement concrete. So for Portland cement concrete, we mix cement powder with water. So we have cement paste. And then we mix the cement paste with sand and coarse aggregate. So we have Portland cement concrete. For asphalt concrete, the asphalt will be the binder. Same role as Portland cement paste. Okay, but at room temperature, asphalt is a semi-solid. How we can mix them with sand and coarse aggregate? So we need to liquefy them. Okay, how we liquefy asphalt? We have three different methods. So we have three different asphalt products. For asphalt cement, liquefying method is heating. So we increase the temperature of asphalt cement, so liquefy them. Or we can dissolving into a so-called petroleum solvent. In that case, we call that asphalt cutback. Or we can emulsify with water. Okay, in that case, we call that asphalt immersion. And asphalt cement is by far the most commonly used asphalt product. And let's look at asphalt cement first. Okay. So asphalt cement is the first type and the most commonly used one. It is residual from crude oil distillation. The consistency, which is how easy the asphalt cement can flow, depending on the source of the crude oil, the refining process, and also amount of lighter fraction removed. Okay. It is semi-solid under room temperature. Okay. To make it liquefy, it needs to be heated up. So when we heat up the asphalt cement, the viscosity will be lower, so we can mix it with sand and coarse aggregate. So that's the first type, asphalt cement. The second one is asphalt cutback. Okay, so asphalt cutback is produced by dissolving asphalt cement in a lighter molecular weight hydrocarbon solvent. Okay, the hydrocarbon solvent is also coming from crude oil. So the property depending on the types and amount of the solvent. The curing rate, which is how soon the asphalt cement hardens, depending on the type of solvent we use, and viscosity, the function of how much solvent we added. If we need the solvent to liquefy the asphalt cement. The solvent will eventually evaporate to the air, so asphalt cement will harden. Okay, because the asphalt cement is coming from the crude oil, it used to be cheaper, but the price depending on the price of crude oil. Another drawback of asphalt cutback is it is not very environmental friendly because the solvent will evaporate to the air. Okay, so that may pollute the air, cause some pollution problems. The third type is asphalt immersion. Okay, so asphalt cement for asphalt immersion is physically broken down into smaller size globule. Okay, that will be mixed with water. The water has a small percentage of so-called emulsifier agent. Okay, the percentage of emulsifier agent is very small, only about 1% of total. Okay, so for asphalt immersion, we have 60 to 70% of asphalt residue, about 30 to 40% of water, and 1% of emulsifier agent. Okay, emulsifier agent is similar to chemical admixtures, such as superplasticizer we use in Portland cement concrete. Okay, let's look at the molecule. The molecule of emulsifier agent has two different sides, two different components. We have a head with electronic charge, and also a tail which has high affinity for asphalt. Okay, so similar to the molecule structure of superplasticizer. Okay, and the function of the molecule for emulsifier agent and the superplasticizer is also kind of similar. Okay, as we can see, the head is hydrophilic, which means it likes water, and the tail is hydrophobic, which means it hates water. Okay, so the tail will attach to the particle of asphalt. So the surface of asphalt particle will all be negative charge. So they will repel each other, and that's how we can emulsify the asphalt emulsion. Okay, again, very similar to how superplasticizer works. So for asphalt immersion, the setting, which is how soon the asphalt will harden, okay, is phenomenon of separation between the asphalt residue and the water. Okay, in the water we have small percentage of emulsifier agent, and rate of emulsifier setting is controlled by type and amount of this emulsifier agent. And it is more cost effective because mostly we have water and only small percentage is emulsifier agent. And it's also more environmental friendly because not a lot of solvent is used in asphalt solvent in the second type. So before we talk about the testing method for asphalt, let's talk about the special property of asphalt. Asphalt is very temperature sensitive materials. Okay, this is different from Portland cement concrete. Portland cement concrete is not very sensitive to temperature. So increased temperature, reduced temperature 20 degrees, 30 degrees will not change the hardening property of concrete quite a lot. But for asphalt, it is very sensitive to temperature. So increase the temperature 10 degrees, the viscosity will be reduced quite a lot, which means it becomes softer. Okay, reduced temperature, the viscosity will be higher, it becomes hard and more brittle. Okay. So for a certain type of asphalt, we have a certain so-called optimal range for viscosity. And because viscosity is depending on the temperature, so for a certain type of asphalt, we have the optimal range for temperature. Okay, so at the end of this class, we'll try to select which type of asphalt for certain location. Okay, because in certain location, the temperature range will be different. Okay. So the grade of asphalt cement should be selected according to local climate. What is the highest temperature? What is the low temperature for a certain local climate? Traditional test method for asphalt, including penetration test, or we can measure the viscosity of asphalt cement. For example, this is the penetration test. We measure the consistency of asphalt cement. So the test is controlled at 20 degrees Celsius. Again, because asphalt cement is very temperature sensitive. Okay. We use a needle with a certain weight. A needle will penetrate the asphalt cement for 5 seconds. And depending on the penetration depth, okay, so we can have a judgment of the consistency of the asphalt. So a larger penetration value indicate a softer materials. Okay, so this is a very simple test. We measure the consistency of asphalt cement, but this test does not give us idea of actual performance of asphalt. So we do not know how the asphalt will perform in a certain pavement. So that's the reason we have later on a so-called performance grid test. So the performance grid system was developed by Federal Highway Administration. Inside Federal Highway Administration, we have the Strategic Highway Research Program, or SHRP. It is developed around 30 years ago. Okay. So compared to the traditional tests, such as the penetration test, so the performance grid specification designed to provide performance related to property of pavement. Okay. For example, okay. So for this test, the name is called rolling thin film oven test. This is one of the ASTM standard tests. So this test is to simulate the short-term aging process of asphalt during the production period. Okay. So in the production period, we heated up the asphalt and we mixed asphalt binder with sand and coarse aggregate, and then we pave the road. Okay. So we do that in the first day of construction. And this rolling thin film oven test is to simulate that first day, the short-term aging process. Why we care about the first day? Because during the production period, we increase the temperature of asphalt binder. And during that process, we have a lot of heat due to the high temperature. Okay. So this is the rolling thin film oven, as we can see in the picture on the right. We have some special glass bottles in the rolling rack. Okay. So the binder is poured into these special glass bottles. As you can see from here, it's not very clear. The bottles is in the racks, and the rack is rotating inside the oven. The temperature is again well controlled at 160 degrees Celsius for 75 minutes. Okay. And then we check how much weight lost of the asphalt binder during that process. Okay. And then after that, we can do other performance tests, such as shear, compression, and creep test, and tension test. Okay. So again, this test, the rolling thin film test, is to simulate the short-term aging process, the first day of construction. And the next test, the next test is here. It's called pressure aging vessel. It's also an ASTM standard test. For this test, the purpose is to simulate the aging process of asphalt over its service life, 10 years or 20 years. Okay, this is a slowing aging process. The asphalt binder is first aged in the rolling thin film oven. The first test we just talked. Okay. Then we force oxygen into the sample. The oxygen will age the asphalt binder over time, but it takes 10 or 20 years. How we can accelerate that process? So we use vacuum oven to remove the air bubbles before the test, and then we age at certain temperature. This is about 100 degrees Celsius, depending on the grade of asphalt. We also apply high pressure because we want to accelerate the process, the aging process. So for 20 hours, we can simulate the aging process for 10 or 20 years of asphalt. Okay, and after that, we can do some other tests such as shear, creep, and other mechanical property tests. This is another test. It's called flash point. Okay, because we do not want asphalt pavement to burn after a car accident. We want to know what is the flash point for asphalt. For this test, it's pretty simple. We just increase the temperature of asphalt, and then after several seconds, we pass a small flame on the top surface of the asphalt, and we see what is the flash point for the asphalt cement. Okay, so this is a safety test to measure the flash point of the cement, asphalt cement. This is viscosity measurement. We measure the viscosity of asphalt binder. Okay, this is called rotational viscometer test. In this test, we have the coaxial cylinder tap. Okay. Coaxial cylinder means we have rotational spindle, which is inside a chamber. The chamber is also cylinder shaped. Okay. And in the sample, we have asphalt cement in there. So the asphalt binder is shared between the cylinder, spindle, and the chamber. Again, the temperature is well controlled at 135 degrees Celsius. And we can calculate the viscosity of asphalt based on the torque and also speed of the spindle. Okay, so this is a very commonly used viscometer. We can use this for asphalt, and also we have used that for Portland cement paste. Okay. For other performance grade tests, including shear, bending, or tension tests, this is for mechanical property of asphalt. All of them are ASTM or AASHTO standard tests. Okay. We just skip the details of these tests. All right. So the last part of this today's lecture, we talk about how we can select the asphalt based on local climate. So asphalt binder can be classified based on performance grading. This is a new type of grading which we'll focus in this class. Okay. And this table shows us all available grades for asphalt binders. Okay, the name of a certain grade starts with the PG. PG means performance graded. Then followed by two numbers. So the first number is the maximum pavement design temperature. The temperature unit is in Celsius. Okay. The second number is the minimum pavement design temperature. Okay, it will be negative number. For example, minus 22 means the design temperature, minimum design temperature is minus 22 degrees Celsius, and the maximum temperature is 58 degrees Celsius. So for a certain degree, we have high temperature. For example, we have 46 degree, 64 degree, or 82 degree. So depending on where you want to put your asphalt into. Okay. So in warm temperature, tropic weather, we're gonna increase the design temperature. In Alaska, you're gonna reduce your low temperature grade. For every grade of high temperature, we have several different low temperature grade. For example, for PG70, we have -10, -16 to -40 to choose from. Okay. So then let's look at how we can select the performance grade of the asphalt depending on the local climate. So to satisfy the maximum and minimum design pavement temperature, we need the local history of temperature. Okay. So the maximum temperature of the pavement will be the highest average 7-day temperature. Okay. But for the minimum temperature of the pavement, it will be the lowest 1-day temperature recorded. Okay. And we also need to consider the reliability level, which is the percent probability in a single year that the actual pavement temperature will not out of the range of maximum and minimum temperature. Okay. It is also assumed that the design high and design low pavement temperature will follow a normal distribution. Okay. From CE375, we learn different type of distribution. And one of them is called normal distribution. Okay? And we assume the temperature will follow normal distributions. Okay? And let's look at an example here. So the question tells us the average 7-day max pavement temperature is 56 degrees. Okay? And the standard deviation is 2 degrees Celsius. We're going to use the standard deviation and the 56 degrees Celsius to calculate our design temperature. For the average medium temperature is -23 degrees Celsius, with the standard deviation of 4 degrees Celsius. Okay. So the question asking what standard PG grade the binder should be selected with reliability level of 98%. Okay. All right. So let's first review a normal distribution. For a normal distribution, okay, so the curve shape doesn't change. Okay. So the mu is called population mean, which is the mean value in the middle of a normal distribution. And the standard deviation, we call that sigma. And the percentage is shown here. For example, 34.1%, it is a probability a certain random value will fall between mu and mu plus 1 sigma. Okay. All right, and we can see that for the value larger than mu plus 2 sigma is around 2.2%, plus minus. Okay, so that means a randomly chosen value higher than mu plus 2 sigma, so mu plus 2 standard deviation, the chance is around 98%. Okay. For the same reason, a randomly chosen value lower than mu minus 2 sigma is also about 98, only about 2%. Okay. So for reliability level of 98%, we should calculate mu plus minus 2 sigma. For the higher temperature, it should be larger than the average 7D high temperature, which is 56 degree. It be plus 2 sigma. Okay, the standard deviation is 2 degrees Celsius. So 2 times 2 degrees Celsius. So the high temperature should be larger than 60 degrees Celsius. Again, because for reliability level of 98%, we want the mean value plus 2 sigma. So this is 98% reliability level. For low temperature, it will be opposite. So the low temperature need to be lower than the low 1D temperature, which is minus 23 degrees Celsius. It will be minus 4 degrees is the standard deviation, times 2 is 2 times standard deviation. So that is minus 31 degrees Celsius. Okay. All right. So why we do that? Let me write something for you to help us better understand why we use plus for the high temperature and we use minus for the low temperature. Okay. So the question tells us the minimum and the highest, the maximum temperature. The minimum temperature is minus 20 degrees Celsius. Okay. Standard deviation is 4 degrees. Okay. The high temperature is 56 degrees with a standard deviation of 2. Okay, so this is local temperature we get. So for 98% reliability level, okay, we want the high temperature to increase 2 times 2 degrees. So that is 60 degrees. So we want to increase the range further to 60 degrees Celsius. So we increase the range. For the low temperature, we also want to increase the range by reduce the low temperature. So reduce the low temperature to minus 25 degrees. Again, we minus 2 times 4 degrees Celsius. So that is equal to 31 degrees. Oh, that should be 33 degrees, sorry. Okay. So 33 degrees, right? 25 plus 2 times 4 degrees, so that's 8. So that should be minus 33 degrees Celsius. Okay. So we increase the range from minus 25 to 56 to minus 33 to 6 degrees Celsius. Okay, because we have 98% reliability requirement. All right, so the degree, the grid will be 60 minus 23. And then we should look at a table. But in the table, we do not have such a degree. So we should choose the closest PG grade from Asphalt binder. Okay. So the only PG we have closest to 60 degrees, 64. Okay, and that temperature should be higher than 60. And the lowest temperature closest to minus 33 is minus 34. Okay, so this is performance grade available for us to choose. So we further increase the range to 64 minus 34. Okay. So that is how we choose the PG grade. All right. So step 3 is we choose the grade, okay, because we get the high temperature should be 60, low temperature should be it's 23, it's not 25, sorry. So it's 33 minus 33 degree, that's correct. Okay, so we need to further increase the range. The range is 60 minus 31. The closest standard PG asphalt binder grade that satisfies our two temperature grade is PG 64 minus 34. Okay, again, remember for high temperature, it should be larger than high temperature plus 2 sigma. For low temperature, it will be smaller than low temperature minus, again, minus 2 sigma. Okay, and then the grade will be further wider to cover that high and low temperature range. Okay, that is how we select the PG grade for asphalt binder. All right, again, we choose from the table the closest one to cover the high and low temperature. So 64 minus 34 is the one to choose. All right, so that's the end for today's lecture. We talk about 3 types of asphalt product depending on how we liquefy the asphalt cement, okay, and how the temperature affects the performance. So increased temperature, the viscosity will be lower, and vice versa. And most importantly, how we choose the grade of asphalt binder. Okay, so please go back to review the sample question we just discussed. Okay, and yeah, so that's the end for